turn to talk.
Okay, thank you, Suzanne. All right, I'm going to go ahead and stop my video and then go ahead and share my screen, and we can get started. Let's see. Can somebody confirm that you can actually see that?
Yep. Yes, we do.
Okay, great. So yeah, as Suzanne said, this is the 6th in a series of 5, and so as oxymoronic as that is, let's move forward. So I'm going to cover basically 2 topics. One is a little more balanced than the other. So I'm going to talk about an overview of the EDI data repository and probably more details about the PASTA software stack, which the data repository actually relies on. And then I'm going to go through, in a series of slides, the use of the EDI Data Portal to show you how to evaluate data packages in the repository, and then to finally upload and publish data packages in the repository itself. First, I just want to make sure the couple of premises here that you are familiar with the Ecological Metadata Language. This is the language that we use within the repository itself, and that you also know, and you don't have to know in details, but you know how to use EML to describe a data package so that when you do upload it into the repository, everything works. So with those 2 premises, let's go ahead and get started because there's a lot to go through. Here's a brief history of where we are today in terms of the software stack and the EDI data repository. It's kind of an annotated version with lots of figures there, but if we really pull out the figures and look at the details here, you can see that things really started to get going in 2009, and I've been leading the effort to develop the PASTA software since 2009. I want to give a shout out to my lead software developer, Dwayne Costa, who has provided a lot of the expertise in the code base. And then also, I just want to point out that a lot of the feedback and collaboration occurred as part of the LTR network, and the LTR network information managers helped really design this. So if anything, this wasn't a small effort, this was more of a village effort to really get this software and data repository in place. If we look at really the highlights here, the development started in 2009. We went into production with, really back then we were calling it the PASTA data repository, which now we're calling it the EDI data repository. But that went in 2013, January 2013. It's in production since. And we transitioned, we finished the LTR Network Office grant in 2015. We transitioned to the EDI grant in July 2016, and thus the change to the repository in 2016. Today we have about 42,000, a little bit more than 42,000 data packages in the repository. And so let's just move forward from there. So what is the EDI data repository? It's an internet accessible open data repository. We're actually funded to support 4 projects from the National Science Foundation. This is part of the the Directorate in Biology. It's the Long-Term Ecological Research Network, the Long-Term Research in Environmental Biology, the Macrosystems Biology, and then the Organization of Biological Field Stations. But we're really an open data repository to any environmental or ecological data that are pretty much size friendly. And what I can't really give you is a bound on what I mean by size friendly, but obviously we have to be considerate of terabyte size data. But most of the data, you know, if it's in the gigabyte size, we have no problems actually working with that type of data size. And the only thing we ask is that new users, if you would just contact one of us before you're going to do any uploads or anything like that, so that we know to expect those data coming in. So as mentioned earlier, the EDI data repository uses the PASTA data repository software. We generate digital object identifiers for all public data packages. We support 2 DataOne member nodes. We have one for EDI that has been in operation now for a little over a year. And then we also support more of a legacy member node for DataOne to support the LTR network. And so we do have those 2 member nodes operational. We have about 42,700 data packages in the repository, and these are data packages, and I'll talk a little bit more about what I consider a data package in the presentation. But if we look at that, there are roughly around 6,300 researcher contributed data packages. We have about 21,000 Landsat image data packages. There's a couple of varieties of Landsat content in there, and most of those Landsat data are for the LTER sites. And then we have roughly about 15,400 Ecotrend project data sets. And these packages are from a synthesis project that occurred a few years ago as partly LTER, but partly other constituents there. We store about 8.5 terabytes of data. The bulk of that data is the Landsat data that we have. The site or research contributed data is pretty much less than a terabyte there. And then we're also a recognized data repository by Springer Nature, Scientific Data, ESA, R3 Data, PLOS, and a number of other organizations. And we're actually in the process of complying with the AGU FAIR data repositories and the core Trust Seal data repositories. So we will be pursuing that here in the near future. So from an end user's perspective, what the data repository is simply, it's an internet accessible data repository where you can put your data into the system and get data out of the system. It can be done all through a data portal where you have a fairly nice user interface to interact with. But under the hood, when you look at it, we have a lot going on. The PASTA software stack is based on a service-oriented architecture, and I'll talk a lot about that towards the latter part of this presentation. But there's a lot of things that interact with PASTA. We have a number of member nodes, we have 2 data portals, we have a couple of LDAPs that we use for authentication. We talk to Amazon Glacier, we have a state of health monitor out there also. Really, from an end user's perspective, all you need to know is that you get data into the system, the data are stored there, and then data comes out of the system upon request. So pretty straightforward data repository. I don't think it's anything extraordinary from some of the other data repositories out there, but it has a lot of nice features. And those features are kind of bundled into the PASTA software stack, and that's what I'm going to talk about right now. So PASTA itself, it's a metadata-driven data repository system. It supports a number of, and these are my personal perspective in terms of what I think are the key or salient features of PASTA. Others may have other ideas here, but let's just go through mine here. So it supports a data package model. That data package model, I'll talk a little bit here coming up. It also supports data package quality evaluation. So all data packages that are uploaded and published through PASTA has to go through a quality evaluation. And if it doesn't pass that evaluation, it doesn't get published into the repository itself. We support provenance tracking as part of the metadata structure, and I'll talk about the provenance tracking. The software system supports strong versioning. This is important because data packages generally are updated over time and the metadata can be modified, so you want to version that information. Any of the past versions are immutable and they're always accessible, so that's the concept there of the strong versioning. We have a DOI assignment at the data package level. I'll talk about that later on. But again, I just want to emphasize it's only at the data package level, not at the individual components of that data package. And then we also support access control at both the package, at the data package and the data object level. And even though we strongly recommend that all data are publicly accessible, we recognize that there are needs for access control. So that is also part of that. And it's also combined within the metadata itself. So it makes it quite accessible to the system and for you as a contributor to set that. The system itself, it's based on a service-oriented architecture design pattern. I'll explain that a little bit more into the presentation. And then finally, we also support REST web service interface for the standard create, read, update, and delete operations that most of the repositories out there today support. So those are the main points of what PASTA is. As I mentioned, these are based on my perspective, and others may have a different perspective. So let's get into the meat of it then. So what is a data package? A data package from our perspective is an assemblage of science metadata, in this case the EML, and one or more science data objects, which could be, say, a comma-separated value table or a Landsat image, for example. PASTA data packages include a quality report. Those reports are generated as a side effect of the quality evaluation process, but those are also included in the data package. And we also have something called a resource map, which is in essence a manifest of what consists in that data package itself. So those are those two extra components there. And it's those four components that form what we call the data package in PASTA. So as a user, if you're contributing to the repository itself, you're only responsible for the science metadata and the science data. You don't have to worry about that quality report or the resource map itself. So it makes it quite easy to contribute to the environmental data repository. We have a unique package identifying system within the repository. This is based on kind of a legacy system. Some of you are familiar with Metacat. We were one of the original communities that supported, I should say, the LTR network was one of the original communities supporting Metacat. So we have followed through with their identifying system. That example right here is what we would see in a typical data package identifier. That identifier is broken into three components. There's a scope component, the identifier component, and the revision. The scope component itself, it's simply a string value, and that string identifies, say, the organization or the project or the theme of the data package itself, and may have broad bearing across a number of data packages in the system. The identifier is an integer value. That integer value uniquely identifies that data package within the namespace of the scope. And this is kind of the accession number, if you would, in some of the other data repositories that you may be familiar with. And then finally, that last part of the identifier is the revision value. And it also is an integer value in increasing order, and that revision value identifies the version of that particular data package. The only thing unique about this revision value is that it must be in increasing order, so subsequent revisions or versions must have a higher value for that integer value from previous values. As I mentioned earlier, it's a metadata-driven data repository software stack. We standardized on the Ecological Metadata Language, EML. EML is based on an XML schema. It's defined by that schema. The current version is 2.1.1, and there is active development going on. There should be a really nice release coming out. It's been, I think, 8 years in the coming, but this new version 2.2.0, I believe, will be the version number, should be out probably within the next month or two, and I look forward to that. The EML itself describes the full data package, and it provides you a lot of extensibility within that metadata schema to describe scientific data. And it isn't necessarily maybe a misnomer being called the Ecological Metadata Language, because you can actually use it for a number of different types of scientific or research data itself. The diagram on the right is a snippet of the kind of the graphical hierarchical view of the XML itself. I don't expect you to really read it or see it in any detail, but it just kind of gives you an idea of the structure, at least at the highest level. So if we look at EML, what does EML provide PASTA? So EML can describe the access control of both the full data package and or the individual data objects itself. It describes who was involved in the research, not only at the individual level, but it can describe both organization and roles. It describes where the research occurred based on a geospatial coverage, and it describes also when the research occurred, the temporal coverage of that particular data package. It describes how the research was conducted. It describes what was researched, in other words, the type of data that you're actually describing within the metadata itself. And the type can either be like tabular, spatial, database connection. It can describe, in other words, blobs, also just binary large objects and things like that. You also describe physical attributes of that particular data, including the size. It could be the checksum value or the source location of that data. And then you also have the ability to describe at the attribute level. So this is really important for things like tabular data, so you can describe in great detail column information, so we know exactly what type of data we're describing with this metadata. So it's really nice to be using EML. If I were to say what is comparable out there in the working world to EML, I'd say ISO 19115 is probably at the same fidelity, but I believe that EML is actually a much nicer standard to work with if you've worked with ISO 19115 at all. It seems so much more human readable to me than the ISO standard itself, but that's again my personal preference. So when we think about PASTA and the repository and how the workflow executes, it's actually quite simple. So from a user's perspective, the only thing that really needs to occur is the metadata, the EML, needs to be uploaded to PASTA itself. PASTA relies on the information within the EML, so it parses the EML from the information as to the location of the data. It then uploads that data into PASTA. It performs the quality evaluation processing, so it's comparing what you put into the metadata and the data itself, and I'll talk in more detail about that. It mints and registers DOIs, so it actually creates the DOI representation and registers that DOI with DataCite. And then at that point, we consider that data package to be published within the repository itself. We also have an evaluation process, so if you really want to just kind of confirm that the content is good, the quality checks and everything are going to go through, you basically follow the same process. You upload the EML, the metadata, to PASTA. It parses that EML, it uploads that data, and then performs that quality evaluation. As a side effect of that evaluation, it generates what we call a quality report, and that report is then accessible to you, so you can actually fix any issues that may occur. Or if everything looks good, then you can proceed to the next step and actually publish that data. Any of those reports also, and I'll show you an example of that, are also stored as part of the content, as I mentioned earlier, as the data package content within the repository. So speaking of quality evaluation, what is data package quality evaluation? So from our perspective, it is a series of quality checks for one, metadata validation. So when I say metadata validation, we're talking about, is that XML that's uploaded to the system to PASTA well-formed? And does it comply with the schema? So if it passes those two checks, things are looking good. Then it does content validation. It actually looks to see what optional content, obviously the required content would fit. If it's not there, that would fail the schema validation. But optional content we also look at to make sure that it complies with best practices of the communities that we're working with. So we do those types of validations. The data validation is fairly simple. It's primarily looking to ensure that those data are accessible, that we can actually download it from the source location into PASTA so that we can perform these types of evaluations. And then finally, we do this what we call congruence validation. And in essence, what it's doing is basically looking at what you have provided in the metadata and comparing that to the structural information of the data itself and making sure that those two are congruent. In other words, that in the metadata that they're the correct number of columns, you have the correct number of rows, the data types are good, you have the right delimiters and things like that, so that it's all valid. Again, congruence just simply means agreement or harmony, and we take that to heart when we're talking about the metadata and the actual data. There's a quality evaluation lifecycle that we recognize. So if you're pushing your EML, your science metadata to PASTA, it's uploaded to the system. The first step is that evaluation lifecycle is to perform that EML validation. The second step is the data validation. The third step is the congruence validation. And then finally, if everything looks good at that point, we consider it to be published. However, if any of those steps fail, then it blocks that publication process and it has to go back to the contributor of that data package to fix any issues with the metadata and or the data. Part of that evaluation process is the report that I had mentioned. And in the report, you'll see 4 different states. There's a valid state, which basically means that the quality check meets the criteria stated within that check. There's a warn, is simply a warning, which means that the quality check may not have met the criteria, but it does not actually fail the upload. We have a number of quality checks where this warning is applied because it may be a best practice that we really want somebody to follow a particular pattern, but if they cannot do it for one reason or another, we don't necessarily want to fail the upload. Then there's an error quality check, which again may not meet the criteria, but this is such a significant state change that we actually fail the upload in that process. So an example would be, say, a checksum value. If your data have a particular checksum and you put that into the metadata and we download that data into the system, we generate the same checksum, and if the checksums don't match, then we're going to fail that quality check and not publish that data set. And then finally, there's an info category also, which basically provides just plain information back as part of the report itself. Here's some clippings from that report. You can kind of see up here, there's the valid status, and we're talking about basically the package ID pattern is correct. There's a number of other valid states that you can see here. The method element is present. You can see a number of warnings here in the yellow color. And those warnings again, so for example, here you may have a keyword that was not added or no keywords that were present, but we're not going to fail the upload of that at that point. And then finally, you do see an error down here at the bottom. And again, this is exactly what I was talking about in terms of the checksum. In the metadata, one checksum is provided, but when we downloaded the data and generated the same checksum, we were getting two different values. So that would technically fail the upload or publish of this particular data package. And there's also that info value right there. It's just a simple geographic coverage present, just basically states that it was present. So pretty straightforward. Switching gears a little bit, let's talk about provenance tracking through metadata. We've been doing provenance tracking by using the metadata structure in EML. We've been doing this for quite some time now, and so it's somewhat legacy and somewhat simple. And all the provenance basically does is allows you to describe from a derived data package. You can state that it is derived from a source data package. Within the source data package, you could basically state that it's used as part of the derivation of another data package. In PASTA, this part is somewhat automated based on information that you provide in the derived data package. And let me just go through here a little bit more. So we use basically the method step in EML for the description of provenance information. In that method step, you have to describe what you're talking about in terms of what type of provenance it is. This is all natural language, so there's no machine readable content at this point. You have to also describe the data source with a title, the creator, distribution location, which is basically the online description and the URL to that. And then you have to also provide contact information. This content is used within the system to automate the provenance information in the source data set, and it's also used in both the source and the derived data set in the display of information in our landing pages for our metadata. So in this clipping, and I apologize, there's a lot of information that I had to clip out, just wouldn't fit on this page, but the point I'm trying to show here is in this particular data package, EDI.20.1, it clearly states that this data package is used in the derivation of another data package. It's the source of that derived data package. And this is the title of that data package. And as I'm annotating here is the source for this data package, EDI 101.1. And down here, you can see where it's highlighted that this data package is derived, again, from this one over here, and this is the title of that particular data package. As I mentioned earlier, these two elements right here in this source data package are generated automatically based on the content in this derived data package. So these are all internal to PASTA here. However, this list of source data package may or may not be internal to PASTA. You're able to document external data sources for provenance, and it will show up in this list as such, and depending on the content you provide, would be accessible again through this landing page. In either case, this content is explicitly stated within the EML metadata that is stored within PASTA itself. Talking about the strong versioning, we use the identifiers in the revision value to support versioning. We don't have an explicit element that has basically the information whether it's being obsoleted by or obsoletes one version or another. It's all implicit based on the revision number that is part of the identifier system. What I'm going to just show here is over time how those linkages actually align as you add new versions of content into the system. So in this case, EDI 10.1, I've added a new revision, EDI 10.2. So the gray arrows are just basically pointing back to the previous version and then the latest version. I also want to demonstrate that the version number, the revision numbers do not have to be in exact sequence. So in this upper one, I have .5, and over here I have a .10. You'll see in the middle one, I have 1, 2, 3, which is the normal sequence of integer succession. And then this bottom one, I'm just showing you that they don't even have to follow a particular pattern as long as they are an increasing value. And then finally, as I mentioned, these are really just implicit obsolescence chains. And based on the values, you can determine who is being obsoleted by and who obsoletes the previous version or the successive version. In the landing page for the metadata on the portal site, you can actually see when you have multiple revisions of a particular data package. I recognize this is kind of hard to see, but if you kind of look closely, you'll be able to see that this is the current version, and based on these annotations below, you can see that there are other versions. If you select all revisions, you'll actually be brought to a page that shows you every revision. As I mentioned earlier, previous revisions are non-mutable, so they cannot change, and they're always accessible to a user, even though they may not show up by default. By default, when you search our system, you always get the latest version, but through the landing page and through the metadata information, you'll be able to go back to previous versions quite easily. Digital object identifier assignments are based on our identifying scheme. At the object level, or at the data package level, I should say, we really have three different types of identifiers within our system. We have what I've been talking about up to this point, an internal identifier, which is based on that three-part scope, identifier, and revision pattern. We have external identifiers, which are more common. They're based on a URI pattern, and this URI happens to look very much like a URL. And in fact, it actually acts as a URL. So if you put this into your web browser and you wanted to get that particular data package information, that would still work. However, they really are and should be considered opaque, and there's no guarantee that in the future that this particular URI will ever resolve to anything other than the data, but it may not resolve as a URL. It may have to go through a separate resolving process. So just kind of a caveat there. All our data packages do receive a DOI. That's our shoulder, the 10.6073. And this is the unique identifier generated for that particular data package. Now again, the data package consists of multiple components. There's the science metadata, the science data, the quality report, and the resource map. But that DOI really only refers to the data package as a whole, not to any of those individual components. The other thing too, and I'm not sure if this has changed or how it's, what the recommendation is, but when we first started working with DOIs, it was highly recommended that the DOI resolve to a public readable landing page. And for that reason, this DOI does not actually return any real component of that data package. What it does is it takes you to our data portal for the landing page of that specific object so that you could actually read about what that object consists of and how to access the individual components. So I just want to make sure people are clear about what that DOI actually represents. As I mentioned, well, I didn't mention, but we've been in operation since 2013. We've been issuing DOIs since 2013. When we set out, we started working with EasyID, the EasyID project out of the California Digital Library at the University of California, and that ended in 2016. And since mid-2017, we've actually been a data site DOI allocating agent. So now when we mint and register DOIs, we don't go through EasyID, we actually register directly with DataSite. And so that's been operating quite nicely at this point. And I think most data repositories who are working within the DOI system are no longer working with EasyID, or that's actually being phased out. So they'll actually also becoming data site allocating agents or working with another allocating agent like EDI. As mentioned, we do support data package access control. Those access control rules are declared within the EML metadata, and those access controls basically state who can read an object of the package, who can write to that data package, and specifically whether or not they can actually update that data package as a new revision, or if they have all those types of permissions against that particular data package. And that's nicely written within the EML document itself, and we parse that information and apply it to how we allow users to access both the data package and the data objects within PASTA. However, the Environmental Data Initiative, this is kind of an aside, but we really stress that all this data is only of use when it's publicly accessible and without restrictions or barriers. So we really advocate for making all data available to the anonymous public user. And in fact, if we look at all the data packages, the 42,700 data packages in our system, I would probably estimate that 99% of all those data are publicly accessible. So you don't have to even log in to access any of the data, that you could just browse to it anonymously, even though we do support the strong access control. And in addition, we also support a default intellectual rights statement. So within the EML, you can state what type of intellectual right or copyright you would like to see applied to your particular data set. But if you don't, we apply and we reserve the right to apply what we consider to be the default, which is the Creative Commons CC0, which is the no rights reserved waiver against the data package itself. So we're happy to accept data packages with their own intellectual right declared in there, but we're also happy to apply the default version to it if you do not provide one also. So getting back to the data package access control, within the EML, at the very highest level, if you're familiar with the EML at that level, you can set that type of access control that really dictates how an end user will be able to access the full data package, including the metadata. However, if you really want people to see the metadata, but you do have a valid reason to make the data private or embargoed, and examples exist that could be like endangered species data is really typical of one case where you want to have things somewhat controlled. You can set that type of access control at the individual object level, which works really, really well. Again, we don't advocate this if possible, but if necessary, it's certainly doable. Here's an example of what you see. The clip on the left is if the data package is actually blocked from public access, you see this type of an error message that occurs. And I recognize that it's not real human friendly, but that's the way it is right now. And on the right, what happens is the metadata then are visible. But in this case, you'll see that all the actual data objects are protected and embargoed. And in this case, this particular site doesn't necessarily want the data not to get out to the public, but they want to track who is actually accessing that data. And it may just require that you have to log in to actually access that data. So they're the two different types of access control that we support within the system. Okay, now a big transition. I'm going to talk a little bit about what a service-oriented architecture is. So this is kind of a general description of an SOA system. It's a collection of interoperable network accessible services that, when working together, form a large singular application. Now, I know you can read that on the left, but I just want to emphasize that. To demonstrate that idea, though, what I have on the right basically is a set of like services, and these are network accessible services, whether it be on a local area network or a wide area network. But in this case, I have somewhat a hierarchical view of service A, and service A depends on service M. It gets some type of information from service M. Likewise, it gets some kind of information from service Y and service N. Service N in itself, in turn, gets information from service Y and service Z, and also from service X. But from an end user's perspective, they don't see any of the internal workings there. In fact, it's quite opaque to them. They don't really need to know what's going on at that detail. All they know is that at service A, they have access to some cool user application that they can access. And this is kind of how we view PASTA and the service-oriented architecture of PASTA. At the detailed level, PASTA has 4 main components. There's a gatekeeper component, which is the public-facing point of reference for all these internal servers. That's what we call a reverse proxy. It also supports our identity management system, so it literally does the authentication and checks on users and things like that. Then there's the data package manager down here. And the data package manager actually does all the heavy lifting in PASTA. It performs the data packaging that we just talked about, the quality evaluation, the provenance management, the versioning of all the data packages, the DOI creation, and supports that access control stuff. So a lot goes on in that data package manager. We have an audit service which performs logging capabilities or functions. So anything that happens within our entire system, we create a log entry, and it's managed through a separate server called audit, and that's managed right there. And then we also have our Apache Solr search indexing capability, which there really is no human interface. There's no user interface directly to Apache or Solr. It's all done through the data package manager. So search goes from like the gatekeeper to the package manager up to Apache and so on. But that's kind of the detailed view of our service-oriented architecture. As I mentioned earlier, you saw this diagram earlier, so there's a lot of interaction going on here. The 2 member nodes interact with PASTA, the portals, we have an LTR portal, an EDI Data Portal. We interact with 2 different LDAP systems, and our authentication system will be changing here in the next year. And all that stuff interacts directly through the gatekeeper, that public interface to PASTA, interacting with these internal services. The storage system and the package manager, we actually back everything up to Amazon Glacier, which is a offline long-term persistent storage for all our data packages. We also have running up in Amazon's EC2 Cloud, the Nagios, which is monitoring state of health, and all that kind of information takes place. So the really nice thing about a service-oriented architecture is the scalability benefits. So you can scale both horizontally and vertically within a service-oriented architecture quite easily. When I mean horizontal scaling to improve like performance and availability, as I mentioned, that data package manager is a beastie. It does a lot of work, and if it's evaluating a bunch of data packages, it may not have time for other things to be going on, so the system may slow down quite a lot. So to scale horizontally, we may want to have 3 replicas of that data package manager. That way we can load balance across those and keep our performance up. Similarly, we also may want to take that data package manager and break it apart. So maybe it's not doing as much work as one unit any longer, and we can break it apart into 2 different servers here. And in addition, maybe we want to add a completely new microservice up here. And so this is what I'm considering, scaling vertically. And really, what we really want to do, given the resources, is to both scale vertically and to scale horizontally to really improve our overall system availability and performance. And then the last part of kind of this concept of what PASTA is the REST Web Service API for PASTA. So REST, if you're not familiar with it, stands for Representational State Transfer. This was based on a PhD done by, I can't remember his name, Roy Fielding, back in, I think it was late 1999 or somewhere around there. But anyway, REST basically, these are web services that support platform-independent computing between different servers. It's basically machine-to-machine computing between different servers. And REST itself is a design pattern for this type of application-to-application processing, but it's based on the HTTP protocol. So if you're familiar with HTTP, there are a number of verbs that are used when you're communicating like with a web server, and you can, in effect, operate like functions that you would normally work within a single like desktop computer. You could do the same thing, but using web-based interactions to do that. So what do I mean by this? So if your typical web browser, you want to get an HTML, you want to look at a web page, we do this all the time, right? We're doing it right now. But to do that, the web browser makes an HTTP GET request to the web server processes that request, and then it responds with HTML back to the web browser, and the web browser renders that HTML to a really nice, usable look for it. And so what we're talking about, so this request response is the typical, what I call the web browser web server request response lifecycle. Now we can do the same thing with the REST web services, and the nice thing about REST web services is that it is completely operating system independent. And instead of basically making that request for HTML, in this case it's kind of making a request for a particular function using those HTTP verbs, but I can make that request from, say, a Windows desktop system to a Linux server or an OS X server and get that response back. And it doesn't matter what operating system either is running because this is very independent of both the operating systems and not, actually more importantly than the operating systems, it's independent of the underlying software stacks that are involved in this request response lifecycle. So I can make a request from a Windows server that's running Java to, say, a Linux server running Python. Python returns that XML to that Windows server, and then it consumes that XML and does something with it. And it makes it really nice to build these service-oriented architectures within this web service pattern, this design pattern. So PASTA and the EDI data repository relies on a REST API for interaction outside of PASTA, and actually internally also it uses those REST APIs. But Data One uses the REST API to communicate with PASTA. The portals, both the LTR and EDI data portals, interact directly with that REST API. And external users, actually, there are a few people, including, I know John Porter's on the call right now, wrote a really nice application to generate different types of code that does the data loading based on the metadata. He uses that REST API to communicate with PASTA itself. So it works really well. So the web services, they support what we call the CRUD operations. As I mentioned earlier, you stand for create, and often with the create, when you're creating a resource, you use an HTTP post verb. To read a resource, like a metadata document, you use an HTTP get verb. To update a resource, like if you're doing a new revision, we often use put. In PASTA, we use put to delineate that. And then finally, if you want to delete a resource via the web using a REST API, there is actually a delete verb also that can be used. In PASTA, here's a list of real common operations that we use with the REST Web Service API. So for example, if you want to list all the content in PASTA, you're not actually getting the metadata or a data back, but you want to see what's in PASTA, we have these things called list functions, which rely on the read or the get HTTP verb. So we can list scope values, we can list all the scope and identifiers in the system, or for a particular scope and identifier, you can list all the revisions in PASTA itself. Similarly, if you wanted to get that particular resource, a metadata or data or a quality report, there are the get functions, the read functions to do that also within PASTA. And then there's some of the more, I wouldn't say more complicated, but they are a little more complicated using HTTP post, put, and delete. But if you're uploading or creating a new data package in PASTA, you would use a post verb. To do an update, as I mentioned, you use a put. To do an event subscription, say in PASTA in the EDI data repository, we support this notion of event subscriptions where if you're interested to be notified when data are uploaded of a particular sort into PASTA, you can subscribe to that particular event, and you do that with a post. And then finally, there's also the delete capability. And we don't publicize this very much, but there are cases sometimes when you don't want those data packages to be listed in a search, and so you can remove them. They're physically still present on the system, and they're always going to be retrievable if you know the particular pattern, the URL to access that content. But in effect, it's not searchable any longer within that system. Right now, this is actually going to be changing here over the next week or two, but there are 66 total REST web service methods, at least in the development server, or development tier, I should say. If you want to look at these functions, all the functions that we provide, here are the two URLs that you would use to access, and these are kind of like legacy documentation. We have a little different documentation going forward, and I'll just mention that at the very end. But I guess the important part of the web service API is it doesn't matter what client you're using to access that content. It doesn't require a specific type of application other than one that interoperates on the internet. The one on the left here, I'm using just a simple web browser to display the EML metadata content. But the view on the right, and again, I don't expect anybody to read the details, but I use an application called curl from a command line window to access the exact same content between those. And that's what makes the web service API really powerful. It can access it in many different ways. Okay, this is kind of the last part of my presentation, and I call this the 4 steps to EDI data happiness. So it's really simple, and we've always strived, and again, working from the first principles in terms of developing this data repository, the software, we strive to make this as simple as possible and to work seamlessly into the workflows of the LTR information managers. And it hasn't really changed all that much. But the first step in uploading or publishing data is that you have to log on using your user ID. Currently, there's no simple way to create new IDs because we want a lot of control over who's uploading content into PASTA. We're not restricting the user IDs, but you do have to ask for a user ID explicitly. The second step is that you reserve your data package identifier. We have a reservation mechanism. And this is not technically required, but it just makes it a lot easier so that you avoid namespace collisions, so that you don't reuse an identifier that somebody already is using. Step 3, we recommend, and we highly recommend, that if you're working with sort of a new data package, if you're writing new EML and you're not certain of your data objects and things like that, we really recommend that you evaluate your data packages before you try to upload the data packages. In fact, we do this so much, we provide basically a replica system called our staging system, where we recommend that if you're doing something really cutting edge on your side, that you use our staging environment to actually evaluate and upload your data packages so you can see how they look, and if they stick and you like them, then you can actually put them into the production system, which is basically this last step here. You upload your data package and publish it in our production environment. So let me go through a couple of screen captures for each one of these 4 steps. So the user login, it's again straightforward. We have in our header on our data portal, and this is basically both portals support this time, but this is all from the EDI Data Portal. So there's a login button here, so you click on the login, it gives you the typical login prompt. So there's a form field for your username and your password, and there's 2 affiliations right now. So there's EDI or LTER, and once you log in, then you'll see the typical welcome back M. Servilla right there, and you'll see that on the home page. Actually, on all the pages, you'll see who is currently logged into the system. So after you log into the system, you'd want to reserve a data package identifier. There's a tools menu, and to access, you can actually see the menu, I believe, but if you try to access any of these tools and you're not logged in, you'll see an error message. But in here, step 1, you want to go to the reservation section. And once you get to the reservation section, it'll show this particular page. And you can select how many reservations, how many package identifiers you want to reserve. And I'll just leave this as 1. I think Dwayne could correct me or somebody, but I think 10 is the max right now. But let's just go with 1. And once you select that and you reserve that identifier, you get a message back that says your identifier has successfully been reserved. It gives you the complete distinguished name of who did that, and it tells you exactly what scope and identifier value you have just reserved. Now, you don't get to pick these. This picks them automatically for you, so it's basically filling holes and gaps, or what values are available. But you want to remember those. Also, from this page, you'll be able to see all the reservations that you have, so you can see which ones you can use as you go forward. The next step is you want to evaluate your data package. Again, at the Tools menu, there's an Evaluate Upload Data Package tool. You select that, and here what you're going to do is typical upload form. You choose your EML metadata file. In this case, I've named it, the file name is EDI.98.1. It's the XML EML file itself. There's a little bit of a variance here, which is fairly new. I guess it's not all that new, but so in history, when we first started out, we pretty much assumed that most of the LTER sites had their own web servers where they could stage their data. But we also recognize that some researchers may want to just upload directly from their desktop. And what this one checkbox does is it allows us to actually manually upload the data from your desktop system directly into this portal, and let the portal act as a staging environment for your data. And so what I would do then is I would check that box at step 3, and then don't select upload, but select evaluate. And the next step in this processing will be that it would bring up an extra form window that allows you to bind the data file that exists on your computing desktop to the entity name within your EML document. And once you do that, you can select evaluate, and then the evaluation process will proceed. What actually happens at this time is both the EML is uploaded to Pasta. In this particular case, the data file is sitting on the portal server in the staging environment. It's just cached there temporarily. And then the evaluation process takes place. And what you'll see is the output from that evaluation. You can see that there's a report if you wanted to look at the detailed report, but the summary of this evaluation, in this first example, I have 1 warning and 2 errors. And this would actually prevent that upload or publishing from occurring because of those 2 errors. Now, the warning, again, will not stop the publication process. It's just informational at that point. But what I need to do, or as a user, you would need to look at the report to determine what the errors were, and then correct those errors, and then reevaluate that going through that same process. And after I fix those 2 errors and I fix that warning, you'll see that we had 0 warnings and 0 errors, which means we're basically good to go. And you can see right here it says that it was evaluated. Once that occurs and you're happy and you know everything's going to work, then I would recommend that you go through this very similar process to upload and publish your data package. So right here, you can see again, you select the Evaluate Upload Data Package, you choose the EML document, select the manual upload, and then instead of selecting Evaluate, you literally select Upload. You again bind the local data the desktop data file to the entity name within the EML, and then you select Upload. And then finally, you get this evaluation upload result summary. And again, it says now uploaded, yes. Again, the 0 warnings and 0 errors. You can now go to the portal and to Pasta and look at the landing page for the object that you just uploaded, the data package you uploaded. Here's the EDI 98.1 package identifier, and you can see that it is in the system and everything looks good. Yay, success. We're coming to the end here, and I know we're almost done with our hour. If you're familiar with UML sequence diagrams, this is a detailed set of events that occur within the user, portal, Pasta, and the components of the Pasta and data site space to show you exactly what happens when you upload a data package into Pasta itself. Finally, the last slide here, there are a number of resources. Most of our documentation is on the Read the Docs. It's there at pastaplus-core.readthedocs.io. As I mentioned earlier, there's the package API and the audit API. You can access those directly. Those are kind of the legacy documentation we have. We have a GitHub that all our software exists as Pasta Plus under the Pasta repository. There's also a number of examples within the EDI org GitHub under tutorials if you want to see how to interact with Pasta. And then finally, if you do have any questions, feel free to send us an email at info@environmentaldatainitiative.org. So I will stop there and open the discussion to any questions. I know there was a lot of information presented, and I thank you for your patience.
Thank you, Mark, for the great presentation. Very informative and interesting. And I just want to say people can also enter questions into the chat window if you prefer to do that. Mark, could you unshare your screen? Thanks. Yeah.
You're welcome. No questions. Okay. Well, I just would like to thank everybody for attending. I hope it was informative. If you do have any questions as time goes on, feel free to send us an email or contact one of us in EDI. We'd be happy to answer them for you. So thank you again, and I hope you have a good day.
Thank you, Mark.
Thanks, Mark.